Adding and subtracting rational expressions is a lot like adding and subtracting fractions. The same rules apply. So to add or subtract fractions, you need to get a common denominator. Same thing applies here. If we're going to add 1 over 7x plus 1 over x squared, we need a common denominator. And so we've been talking about using the prime factorization to find a common denominator. If you look at 7x, its factors are 7 and x. That's it, right? If you look at x squared, what are x squared's factors? X and x. So to find out the lowest common multiple of those two, take the x that's common, and then take the other two factors that aren't common, but that x that's common, you only take one of those, and then take another 7 and an x. So the lowest common multiple is actually 7x squared, right. So then we need to look at, once we find that lowest common multiple, what do we have to multiply the first denominator by to change it into that lowest common multiple? So we have to change 7, what do we have to multiply 7x by to change it into a 7x squared? X. If I multiply the denominator by x, I also have to multiply the numerator by x, right? Because then I'm just multiplying by 1. That keeps coming up again and again, right? We multiply by 1 to change the way something looks, but keep its value the same. So I'm going to multiply that by x over x. What am I going to multiply the other one by? 7. So really what I'm doing to find out that 7 or that x that we're multiplying by is taking the lowest common multiple and dividing it by the denominator that you have. And that's what you multiply by. So now I'm going to go x times 1 is x. And then x times 7x is 7x squared. Plus 1 times 7 is 7. You could write out two complete separate fractions there, each with that denominator, but I'm going to put them together right away, mainly because it's going to save a whole lot of space later when the denominators get really big. But right away, they're already in one fraction, and actually right away, this one's done. Because you can't do anything with x plus 7 to simplify it. No like terms or anything. And the denominator, we already figured out, should be that. Well, it's almost done. What am I missing? Non-permissible values. So what can x not equal here? 0. X cannot equal 0. That's all there is to that one. What's different about this one? It has a trinomial in the denominator. Oops, that's not what I want it to do. Let's get rid of that. So, first thing we're going to do is find a common denominator, just like we did before, but we have to do it by factoring the denominators. So we have to start by factoring. We'll make this 2x plus 2 over, this is going to factor to x plus 6. X plus 6 times x minus 2 for that denominator. The other one, so it's minus x plus 1. What does this x squared minus 4 factor to? X minus 2 and x plus 2, because it's a difference of squares, right? So for the common denominator now, remember how we did it? These are already in their prime factorization form, so I'm not going to write it out again. I'm going to look at what's common in the two denominators. X minus 2. So I'm going to take those and make that part of the denominator, and then I also need to include the other stuff that's not common. So the x plus 6 and the x plus 2. That's the common denominator. So take one of the thing that's common and then each other thing as well, just like we did in the last one. And then I need to look at, well, what do I need to multiply each denominator by to change it into that? So x plus 6 times x minus 2 has to multiply by x plus 2, because that's the factor that's missing. X plus 2 and x plus 2. So this is the second step. Multiply each fraction to make equivalent fractions with the lowest common denominator as the denominator. So what I have now is 2x plus 2 multiplied by x plus 2 minus x plus 1 multiplied by, what do I have to multiply the second one by? X plus 6. X plus 6, because I already have the x minus 2 and the x plus 2, so these two parts, it's just that that's missing, so that's what I multiply by. And I like to write it all out in the numerator like that before I do any expanding. Just keeps me from making mistakes. So the numerator that we had multiplied by that factor, and the numerator that we had there multiplied by that factor. Then I need to expand that whole numerator and simplify. And that's the third step. Expand the numerator and simplify. When I expand that numerator, I need to use the distributive property. So I'm going to go 2x times x is 2x squared. 2x times 2, that's, oops, made a mistake already. We're not off to a good start. That's 4x plus 2x plus 4. That's just the first two binomials multiplied together, right? So minus, and then I'll go x squared plus 6x plus 1x, which I'll just call x, plus 6. That's the numerator, and then it's all over this denominator.
Wow.
It's long, isn't it? Now we need to combine like terms, simplify the numerator. I have 2x squared minus x squared. Those are like terms, so that's x squared. And then I have 4x plus 2x minus 6x minus x, which is negative x, isn't it? Right, that was these terms. 4x and 2x, that's 6x, and then 6x and 1x, 7x, but we're subtracting that, right? So 6 minus 7, negative 1. And then I have 4 minus 6, negative 2, x minus 2, x plus 6, x plus 2. Now some of you might want to not write that denominator every step, but you have to, because I'm saying that this is equal to this, is equal to this, is equal to this, and without the denominator it's not equal. What you can do at this point, if possible, is factor the numerator. Will that one factor? Yeah, what does it factor to?
X minus 2, x plus 2.
X minus 2, x plus 1. 2.
X minus 2, x plus 1, x squared minus x minus 2. And I'll show you why that step is necessary, and this is what Nathan was asking about, is can you then reduce it? Do you remember when you asked that way back? Anyway, you did at the beginning of class. This one can reduce. What can reduce?
X plus 2 and x minus 2.
The x minus 2 and x minus 2. We're just running out of space here, but we're going to get a final answer now, I think. X plus 1 over x plus 6 times x plus 2. And x cannot equal
2, -6,
2,
-2, or 0.
negative 6, negative 2.
No, not 0. Not
0 is fine. 2, negative 6, and negative 2. The one that was canceled and the other two that are still part of the denominator. And that's the final answer.
Why couldn't you,
Okay.
Here's the last one that we're going to do together today. Start out the same way by factoring the denominators. I'm just going to factor, and you guys can check and see if it seems like I'm right. Good? Okay. So if those are the factors, then what's the common denominator?
X plus 4, X plus 5, X plus 3.
X plus 4, X plus 5, X plus 3. Right. So you take the X plus 4 because once, even though it's in both of them. And then you take the other two. And so when I take that X, that's the first numerator, what do I have to multiply it by? I'm not going to multiply it by all three of them, right? Because I'm just trying to change that first denominator into the new denominator. So it's just the X plus 3. It's just the factor from the denominator that's not already in that denominator. So I'll multiply the X just by X plus 3. Really what I'm doing is multiplying this whole fraction by X plus 3 over X plus 3. Because then the denominator becomes X plus 4, X plus 5, X plus 3, which is what we wanted. And the second one I have to multiply by, X plus 5 over X plus 5. So that's going to look like minus 4 times X plus 5. And then expand the numerator. That'll become x squared plus 3x minus 4x minus 20. And then that same denominator. Combine terms in the numerator. X squared minus x minus 20 over x plus 4, x plus 5, and x plus 3. All right, so that could factor, I think, in the numerator. X minus 5 and x plus 4 over x plus 4, x plus 5, x plus 3. What happens now?
Cancel it out.
Cancel the x plus 4. That actually doesn't happen that often. It did in both of those examples that I gave you because it's something that I want you to remember as a possibility. But you'll find that most often it can't reduce. So this becomes x minus 5. Here's that final thing. X minus 5 over x plus 5 times x plus 3. Shh. And x cannot equal negative 4, negative 5, and negative 3. All of this is the answer.